Hello. This video is supposed to give you an idea how we can use uh, earthquake data, seismic data, to figure out where an earthquake happened, and then also to figure out how big the earthquake was, or the earthquake's magnitude. So there's an assignment that people in class did called Locating an Epicenter, and it involved looking at these seismograms and kind of noticing that there's a gap in time between when the P waves arrive. They're the fast waves, and you can see one's arrived there, there, and here. And when the S waves arrive, and you can see they're the slow waves. This one didn't show up till here, this one didn't show up till here, and this one didn't show up till here. It's possible, and we did this in class, but you don't need to worry about exactly how. It's possible to look at the time lag here and figure out how far away an earthquake happened. So what students did was they went to a map, and if they knew that there was an earthquake recorded in Kansas City, but they didn't know exactly where the earthquake happened, we just got a recording of it, we were able to kind of draw a circle on a map and say, well, the earthquake must have happened somewhere on this circle. And this circle is we figured out exactly the size that the circle needed to be using those seismograms. With that information, can you tell exactly where the earthquake happened? No, you can't. You just know it happened somewhere on the circle. It didn't happen inside the circle, didn't happen outside, it happened somewhere on the circle. So what do we need? We need more data. So let's say that there's an earthquake that was measured. You know what? I did that wrong. Let's say that there was an earthquake that was measured down here around the Cape Girardeau area. And they figured out that it must have happened somewhere on this circle because it happened further away from Cape Girardeau. This is the same earthquake. Could we tell exactly where the earthquake happened now? No, again, we can't because it either happened here or here. We don't know where. We need more data. So let's say we have an earthquake that occurred and it was measured down here in this part of the state of Oklahoma. We could say, if we have these three overlapping circles, we could say, aha, the earthquake must have happened right at this spot. And this spot then is known as the epicenter. It's where it's the place on the surface right above where the earthquake happened down below ground. Okay, so the real takeaway from today is using seismogram data. It's possible to figure out exactly where an earthquake happened. You need three seismograms to zero in on exactly where that earthquake happened. One more thing, it's also possible to use a device like this and one seismogram to figure out how big the earthquake must have been. So if you know how far away an earthquake happened, and you know the size of the squiggle, this is the amplitude in millimeters, if you know the size of the biggest squiggle on the seismogram, and you kind of connect those dots, you can see that this earthquake here must have been a 5.0 on the Richter scale. I hope that's not confusing. Here are the two big takeaways. I'm going to type them. Okay. Important thing number one. Using three seismograms, it's possible to determine the exact location of the epicenter of an earthquake. Important thing number two. Using one seismogram, it's possible to determine an earthquake's magnitude. You don't have to know how. The students in the class did the exercise, but I'm not expecting them to be able to duplicate this in class. These are the important takeaways. Using three seismograms, it's possible to determine the exact location of the epicenter of an earthquake. And important thing number 2, using one seismogram, it's possible to determine an earthquake's magnitude. Go be awesome.